Okay, let's do this. All right, so last time we talked about objects, classes, constructors, references, the keyword this. We talked about quite a bit of stuff. And just to be clear about expectations, I don't really expect, and I'll say all of that, some of that should. I don't expect all of that to make sense after one lecture on it. I threw a lot of topics at you. I got everything out there in one lecture, but I don't expect it to really make sense in the sense of these topics just take a while to sink in. The good news is we have today and Friday. These lectures are just to reinforce everything we saw. So I'm going to be talking about the same concepts. I'm not piling a whole bunch of new stuff on you all week. We're going to reinforce what we saw on Monday. So we didn't get through this memory diagram last time. So I want to recap what we got to and then pick up where roughly where we left off and talk about this memory diagram. So we have a constructor call. We have a player class with a constructor, which is a method matching the name of the class, has no return type, and that's the method that's called when we say new. Well, every time you see the keyword new, we're calling a constructor and creating a brand new object, and then returning a reference to that object that was created and usually storing it in a variable. This constructor is mostly like any other method call, but it and every single non-static method will have a hidden parameter, I call it a hidden parameter anyway, of this, the keyword this, which is going to resolve to a reference that for a constructor is a reference to the object that's being created. And for any other non-static method, it's a reference to the object that called that method. So this, it's a new keyword, something we got to get used to. It's a bit tricky. I'd say this is something that trips up students quite a bit whenever you first learn programming, first start doing some OOP. With memory diagrams, I think it makes it more clear of what is actually going on with this, with the keyword. So when we called the constructor, we created a object on the heap. We put the type of that object and make up a reference number for it. I was feeling 999 when I made the slide. And then inside that object, we're going to create copies of every single instance variable in the class, which are all of the non-static variables that are declared outside of any of the methods. I say non-static just because I'm going to have one example later in this lecture, but that's not something I'm going to do in lecture or on quizzes. They're always going to be non-static. Just one example later today, I'm going to show you a static variable, just so I can talk about static one last time in a class. So we create those variables. They won't have any values yet. And then we call the constructor, put the constructor stack frame on the stack. This stores a reference to the object being created. And I always like to put this as the very first parameter of a method call. Strictly speaking, I wouldn't, for a quiz, I wouldn't mind where you put it. I always like to put it first, if for no other reason, I don't forget to put it there. I put a stack frame on the stack, and I know it's not a static method. First thing I'm going to write is this, just to make sure I don't forget to put it on there. Or else I'm going to forget if I'm like, I'll put this on there some later time. I'm going to put it on right away. So this, a reference to the object that's being created, can be any number, but wherever you have a reference to this object, the numbers have to match. So if I have 999 here, I better have 999 here, and here, 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 here. They better all match, or else it's not clear what that is a reference to, what object is supposed to be being referred to. After this is on the stack, a constructor feels just like any other method call. We have the parameters, name and max HP, name and max HP, assigned to the values of the arguments that we put in those variables. And notice that we don't put HP in this stack frame. We have HP that gets created and is put in the object as an instance variable that does not automatically go on the stack in the constructor call. Only its parameters, just like any other method call, only its parameters are put on the stack, which is only name and HP here. And this, of course. Let's see. Once we call the constructor, we get to the first line, and we see this dot set max HP. The dot operator always means follow the reference. Whatever is right before the dot means whatever's before this is a reference. Take me to your object. So if I say this dot, this resolves to 999. Dot says follow that reference over to the heap. Follow it to the object being referred to. So we're at this object right here, and then we're going to call setMaxHP. So we call the setMaxHP method from this object, meaning in that stack frame, this is going to be a reference to the object that called the method. So this is going to be 999 when we call that method. And then just like any other method call, maxHP, we're being called from this stack frame. MaxHP is 10. So maxHP is 10. And then inside the maxHP method, this dot maxHP, this dot maxHP, we're talking about this variable right here, equals maxHP without a this dot. MaxHP, that means we're looking inside the stack frame still. We always start in the stack frame. We start our search for a variable in the stack frame. MaxHP, we find it in the stack frame. We find 10. So this dot maxHP, that we start the search in the stack frame. This dot maxHP equals maxHP from in the stack frame. So this gets the value 10 over here. We do the same thing for setHP, setName. Same thing going on. This reference to the calling object. And then this dot, we're going over to that object and changing its state. Now notice all three of these setters return void. Whenever we saw void methods before, I said we're calling these for their side effects, but the only side effect was printing to the screen, which is honestly kind of pointless. It's nice for debug purposes. It's nice for showing you simple programs that I can highlight things, but usually you don't do that. The side effect we're really interested in is changing values on the heap. This setName method doesn't return anything, but it has the side effect of modifying the value stored in the name variable of the object that called the method, and we set the value of that variable on the heap, which means we can see that change even after the stack frame is destroyed. The stack frame is removed from the stack, but it made a change on the heap, so it actually had an effect on the state of the program. We can still see the change that this method had, even though it didn't return anything. So we're calling a method not for its return value, but for its side effect of modifying a variable on the heap. So we're going to see a lot of void methods moving forward. They're all going to have side effects. They're going to modify something on the heap. And I quizzed you really quickly last time. I think I just barely got it in last time. But what happens when we initialize P2? And you already saw the answer, but the same exact thing. Same thing happens, same procedure. We're going to see the keyword new. Whenever we see the keyword new, we know we're creating a new object on the heap. If you're doing a memory diagram and you hit the keyword new and you're not drawing a new object on the heap, you're wrong. It's just wrong. You're wrong. New means we're getting a new object on the heap and we're calling a constructor. So we're doing the same process again. We're calling this constructor with new parameters, different name, different max HP, create another player on the heap, pick a new reference. I was just feeling 820 when I made the slide. Nothing special about it. It's just the number I was thinking of when I made the slide. The constructor gets a reference to the object being created. Each time we call a setter, we're going this dot setMaxHP, this dot setMaxHP. We're at this object when that method's called. So this in that method is going to be 820, a reference to the object that called that method. Same procedure as we did the first time. We do get a new object on the heap. We go through all the setters, all of this stuff. And what happens when we initialize P3? A little bit different this time. And hopefully not the same thing again, because I don't have enough room on the slide. So you know it's not going to be the same thing. That's it. Not much happens at all. So we're assigning a variable the value of another variable. So P1, we have to resolve this symbol. What does P1 resolve to? The computer's not going to do anything fancy here. It's going to say P1, oh, I got a P1. I got a variable named P1, and its value is OX999. That's it. That's what P1 resolves to. So P3 gets OX999. You're just copying whatever's sitting next to that variable on the stack. That's its value, and that's what it resolves to. Now, this could be different if we saw some dot operators and that mean follow that reference, go over to the heap, and let's go do some things in the heap. We don't see any of that, so we just get the reference itself. So P3 stores the reference 999, a reference to this object. P1 stores a reference 999, a reference to this object. So what we end up with are two variables storing a reference to the same single object. Excuse me. Is it like grabbing the save file in a game, changing a few things to start a new character? Wait, is this like grabbing a save file in a game and changing a few things to start a new character? I'm not quite sure I understand the question. Do you mean like hacking the save file? Is that what you're talking about?
It's kind of like,
start a new character.
You know, in an RPG, when you can create a character,
Mm-hmm.
kind of like that, where we already got this stuff set up, but all we gotta do is put in what we want new into it.
Oh, yeah. Yeah, so when we're creating a new object, it is like that. So we would create a new object, and then whatever is going to be so the constructor is going to set the initial state of that object, and then that state can change throughout the lifetime of that object. So when we're creating a new character in an RPG, we would say we could even call it new player, and then set its initial stats through the constructor call. That's going to go over to the heap and set their strength, dexterity, etc. And then maybe you have some options during character creation. So after that constructor call returns, then we can call some methods like increase dexterity, decrease strength, and modify your character. Add these buffs and these bless you, and these blanking on the word, but the negative things. And then we can, in code, we would call extra methods after the constructor to modify it in the heap until we get our character created that we want to go into the game with.
Yeah, I think I read in the book it was like to view a class kind of like a recipe or like a blueprint into what you're building. And the condense the variables was like knowledge, and then the other thing, the behavior, was what you're actually doing.
Yeah, I like that. Yeah, your class is like your blueprint that's going to say this is how you create player objects. And the behavior is all the methods in it. That's what a player can do. And then your state is like you say the ingredients? What was the rest of the analogy?
Yeah, I think it was like it's the ingredients to it, or it's knowledge, what it knows.
It's not, yeah, I like that. Yeah, and the instance variables are like its knowledge. This is what this player object knows. These are its properties. That's what it is. But a class being a blueprint that makes objects is, and those objects have state and behavior is absolutely right on. So P3 gets the reference P1. We have 3 variables of type player, but only 2 objects of type player. And you can better believe that this is going to be on the quiz next week. 100%, I will test you on this. It's on the sample, the practice quiz and lab this week. It will be on the quiz next week. I'm going to have something to this effect. There's going to be 3 variables with 2 objects, or 2 variables with 1 object. They refer to the same object. Something where the number of variables is mismatched with the number of objects. And what I'm testing is, do you understand that an object is only created when you call new, and that this is assigned by reference? I will test you on that. It's super important. Throughout your programming career, you have to understand how these references work. So I'm going to hit you right out the gate, your very first quiz after you learn it. I'm going to test you on that. So be ready for that. Please get that one right. I don't like ever seeing that one wrong. Plus, it's super easy to grade that one. If this is a quiz and I see 3 players on the heap, that's an instant fail. You're done. You don't understand references or constructors at that point. Please don't get that one wrong. Study this one. Make sure you know you only get an object when you see the keyword new. So at the end of your quiz, when you're looking over your code and memory diagram and saying, all right, am I ready to submit this? What I would do is say, how many times did I hit the keyword new? Do I have that many objects on the heap? If those numbers don't match, go redo your memory diagram so you don't have to take that second chance quiz. I only see new twice, and they're not in a loop or a conditional, so I know they were each hit exactly once. We should have 2 players on the heap. Not 3, even though I have 3-player objects. I'm not going to get 3-player variables. I'm not going to have 3-player objects. I'm only going to have 2. Make sure you get that one. And let's see the implications. Why is this so important? So if I have p1.setName Paladin, p1 is going to resolve to 999. Dot means follow the reference, so we're at this player. And then we're going to call setName of Paladin on this player. So we have a setName stack frame. This is 999 because this is the object that called the method. Name is Paladin. And then this dot setName, we're going to do this dot name equals name. So we're going to get Paladin, cross out the old value, write in the new value, and then this method returns. This is a method that returned void. It didn't return anything, but it did have an effect on the heap. And that change didn't just affect P1. It will also affect P3 because P3 stores a reference to the same object. So even though I called setName on P1 and called getName on P3, well, guess what? GetName got a reference 999. GetName, this dot name, it's Paladin. So it looks at first glance, before you understand references, it looks like this has nothing to do with this, but they are referring, P1, P3, referring to the same object. A change made to one of them is going to change both of them. And this is true even through method calls. We had a method call that changed P1, so setName got a reference 999. I'm pointing to the wrong one. setName got the reference 999 through the keyword this, made a change, didn't return anything, but still had an effect that's going to adjust another method call through a different variable because of references. If you follow the references and see that 999 bouncing around the code, this should make sense. Should make sense. Yep. It'd be the same thing. So if this was p3.setName instead of p1.setName, this code would function exactly the same. Because p1 and p3, they're both storing the value OX999, so they can be used interchangeably here. The key difference this is going to make, where we really want to be careful of this, because here we control p1 and p3, where we really want to be careful with this is when we're calling a method and we're giving it a reference to one of our objects. And maybe it's a method that we didn't write. Maybe we're calling a built-in Java method, and we're giving it one of our objects. By reference, we have to be aware that that method might change the state of that object on the heap. It might have side effects that we didn't necessarily want. That method might be designed to have those side effects, and we have to be aware of that when we call the method. Just know whether your methods have side effects or not. And when you're writing methods that take references as parameters, make sure you're careful not to change that object that's being referred to unless that's the design of your method. So like if you're writing a sorting method and it takes an array list as a parameter, you're getting that array list by reference, you can actually modify that array list. You can remove elements, add elements, you can rearrange the elements. So if that method's goal is to actually sort the input and then return void, by all means, modify that array list and sort it, because that's what the caller expects you to do. But if that's not what they expect, and they don't expect you to modify that array list at all, if you're writing a different method, like returning the key that maps to the highest value, just out of thin air. I just came up with that. If that's the method you're writing and you're modifying the hash map, which for that method you shouldn't have any urge to modify the hash map. But if you do modify that hash map, whoever called the method and trusted you with their hash map, the hash map's going to be altered when they get it back. It's probably not the behavior you're going to expect or want from the overall program once those two pieces of code are interacting with each other. So we have to be careful with our references. If you get a reference, or if you give a reference, it can change even if the stack frame doesn't return anything. It doesn't look like the stack frame did anything, but it might have the side effect of heading over to the heap and messing with your objects. Maybe you want that, maybe you don't, but you need to be aware of it, that it can happen. And if you want it to happen, make sure it's happening the way you expect. If you don't want it to happen, make sure it's not happening. Yeah?
Do you have to use the setters in the constructor?
No. Yeah, so if you want to, instead of this dot set max HP, you want to just do this. If you want to take this and put it right here instead of the setter, that's perfectly fine. I just wanted more stack frames with this in them for the example. And I want to show you, for your homework, you're going to have to check the range of a rating, make sure it's between 1 and 5. And you'll have to do that in the setter and in the constructor. So if you do that in the setter and then just do this dot set rating, you only have to write that code one time. So I also want to show you this to give you a heads up on that one. It can save you some coding. On the stack? No, not on the stack. Like up here? No, this doesn't change. This stack frame and this stack frame, they're already out of memory. They're already completely destroyed. They don't get modified after the fact. These values were used, well, this value, oh yeah, the one I have highlighted. This value was used to set the value over here, but it was only this variable that changed when we called set name. It was only that variable on the heap. We don't make any changes on the stack. Especially in stack frames. Remember, when they're crossed out, they're no longer in memory, so we don't change those values at all. So these dark cecils don't change after this variable, which is a completely separate variable, got changed to Paladin. Yeah, grayed out means the stack at this moment in time has the variable P1, the variable P2, and the variable P3. All the crossed out stack frames do not exist anymore. In fact, P2 is actually right here, right after P1 physically in memory. P3 is actually right here physically in memory, the way this will actually be executed in the computer. But we don't erase, we don't get out our eraser and erase the stack frames. So we just cross them out to say that they're gone. And the program ends. And of course, we get Paladin. P3.getName, it's Paladin. Okay, so as promised, I'm going to kind of back up. On Monday, I just dove right in and said, okay, here's a class. Let's jump to a memory diagram. Here's all of these new concepts. Today, I want to take a step back and talk about the concepts again without the memory diagram example, despite having a memory diagram on screen right now. And I'm going to use the ArrayList class to explain some of this stuff. So we created our own brand new class just now on Monday. But I want to talk about how the same concepts apply to the ArrayList, a class that we've been on the other side of. We've used an ArrayList. Let's see how an ArrayList got the stuff done, added the functionality that we use. So just a quick recap of how ArrayList work. It's just like our player class. We created a new ArrayList that's calling a constructor, and that's going to create an ArrayList on the heap and return a reference to an ArrayList. That reference we stored in this variable r1. It doesn't get the entire ArrayList, just the reference. And we did r1.add. r1.add is going to add to this ArrayList object. We're calling the add method through that ArrayList. So this in that stack frame is going to be a reference, OX200 in this case. We use the dot operator to follow the reference. And I want to talk about how it does that. So how does that code do what we want it to do, what we expect it to do? And for this, I'm actually going to show a decent amount of the ArrayList class. This is the actual ArrayList class in Java. And if you ever want to see the actual code for really anything, in IntelliJ, if you hold Control or Command, depending on your operating system, and then click on the name of that class, it'll take you to the code for that class. So if I Control-click on ArrayList in this example, if I Control-click right here, it's going to take me to this code. I'm going to show you a significantly cut-down version of the ArrayList class. But if you want to see the entire thing and take a look at absolutely everything that's in there, you can view that code, which can be helpful if you want to see every possible method that you can call on an ArrayList. Jump over to the code, scroll through it, and see absolutely every single method that it contains, every single method you can have in an ArrayList. Your alternate is going online, looking up documentation, which is perfectly fine too. If you do go to IntelliJ, you know exactly for your version of Java, exactly every method that you have available to you. Documentation might be out of date. Though I'd probably recommend doing the documentation. It's going to be more clear than scrolling through hundreds of lines of code or thousands of lines of code. All right, so we imported an ArrayList like this. With that syntax, we know that the ArrayList is in a package named Java Util, and it's in a class named ArrayList. And if we look at the code, we do see package is Java Util, and the class is ArrayList, so everything's happy in the world. It's so far so good. Everything's lining up the way we expect it to. We're going to see some syntax like this. This is a type parameter. This is actually a topic for next week. We will talk about these. Today, I'm going to just pretend that they don't exist, for the most part at least. But that's a type parameter. The short answer is this is what allows your ArrayList to be of any type. So you can have an ArrayList of integer, ArrayList of string, and integer or string in those examples. E would be replaced by that type. But topic for next week, more in depth next week. And then we know we're calling a constructor, new ArrayList, and we give it no parameters. So we know that the ArrayList has a constructor that takes no parameters. There is one line of code in this constructor that I'll show in a little bit. For now, I just want to show that it exists. But we know that this has to exist, and it in fact does. And that it has to be public, because we're able to access this from outside the class ArrayList, and in fact from outside the Java Util package. It means this has to be public. So when we say new ArrayList with no parameters, we're calling this constructor, and it's returning a reference to a brand new ArrayList. And I did show that there is another constructor. We actually saw this shortcut where we can create an ArrayList and give it a parameter. We don't have to give the ArrayList constructor no arguments. We can give it an argument because there actually is an ArrayList constructor that takes a parameter. This is called method overloading. This is true for any method. You can have multiple methods with the same name as long as they have different parameter lists. So we have two methods with the same name, happens to be a constructor. One of them has no parameters, and one of them has a parameter of a collection of something that extends E. We don't have to worry about the syntax there. And this is the constructor we're calling when we use this shortcut, this arrays.asList. Make sure you import arrays if you're using this, and then a comma-separated list of values. This actually returns a collection, and then gives that collection to the ArrayList constructor, gets that collection, and then I removed the code. It's not relevant to what we want to talk about today. But the code, as you would expect, it'll go through the elements of the constructor and add them all into the ArrayList. But with a lot of extra syntax, and it's like 15 lines of code that won't fit on a slide. Not with all the other stuff I want to put on it. So that's method overloading. I probably won't ever throw that. Oh, actually, I can't say that. When we get to recursion, more recursion, actually we'll use that a little bit. We'll see more examples as they come. And then an object is a collection of state and behavior. State, it's all the variables for that object. Behavior, it's all the methods for that object. So you would expect an array list to have state and behavior, and it sure does have two instance variables for its state, an object array and an integer marking its size, its current size, how many elements are in this data structure. And we have behavior. We have the two, oh, my indentation there, it bugs me. We have our two constructors and several methods that we're going to talk about. I'll start with just size because it's pretty much just a getter, but it returns this dot size. Whatever array list you use to call the method, a reference to that array list will be stored in this. It's going to return its size. Okay.
So in this example,
The class would be, so the class is used to create objects. This class is going to be used to create array list objects. But the non-static variables and methods in the class are going to be the state and behavior of objects of that type. And static will belong to the class, but non-static belongs to objects of that class. So we have state and behavior, like we would expect from after looking at our player class. And we can have, I'll talk about that one a little bit, but not on this slide. Our default constructor, I said I'd add this line, it's a one-line constructor. It's going to initialize that element data. Element data is an array of objects. That's where all of your stuff is going to be, your elements of your array list. And we're going to initialize that. If you don't give it any values, it's going to be initialized to this default empty data structure, or an empty array, just an array with no values in it. And that array, do I not put it on this slide? Well, I'm going to talk about it right now. It's going to be a static constant, just like our epsilon was. We're going to have a static constant. That means this it is an object, I guess, but this variable belongs to the array list class. This belongs to the array list class itself, meaning this would be the same as if we put array list dot default capacity empty element data. It'd be the same exact thing. We're going to the array list class. So when we create array list objects get their copy of both of these variables, but not the static variable, because that's not an instance variable. It's a variable that belongs to the class, not objects of that type. So if you call the empty constructor, you get the default empty array list. And we have some our other behavior. There are three methods that are showed in class so far: size, get, and add. So here's the actual code, what executes when you call those three methods. Size, it's what we would expect. I hope there's no surprises there. Get is going to take the index that you specified and get the value at that index from the array. Now this is a vanilla, basic array, so we do use this syntax. Can't use array list syntax because we're writing the array list class. Unless it were a recursive definition, that's not how we're rolling. And then this thing, which I'm going to ignore, but if this were integer, this is what's going to convert this value into an integer. And then add does a little bit different stuff. So I want to talk about add a little bit more. There's a little more code here. And at this point, I should probably mention the details are not important here. I'll never expect you to remember exactly how an array list does this, adds an element. That's a topic for 220. You'll talk about it way more than you ever wanted to. And for right now, I want to talk about this idea of helper methods, and we're going to see another overloaded method. Those are the topics I want to talk about in 116. So this is the add method is overloaded, just like the constructor is. We have two add methods, and this second add method is actually what we call a helper method. And this is something we will see. This is how we'll use overloaded methods when we get to recursion. Actually, I don't even overload them in my examples, do I? I changed the name just to make it more clear. But anyway, we'll use this concept, even if we don't name them exactly the same. But we have two add methods with different parameter lists. And when you call add with an element, what that actually does is calls the other add method with some extra parameters. And then this add method is what actually goes through and makes sure it adds that element to the array list. So this is what's called a helper method, because it's helping out the add method. And then we have this throughout I'll revisit that in a second, but I got to talk about this first, just to get all this stuff out there. This, all over the place, we talked about this a lot during the memory diagram. This is going to be a reference to the calling object. So when add is called, I say my awesome array list dot add some element. We call this method, we get a stack frame for this method, and this is a reference to my array list that I called that method through. So when I call add, it's going to know exactly which array list it needs to add that element to, because it has a reference to that object through this. And then public versus private. So we saw this with the instance variables in the getters and setters. Public versus private. Public is anything that you want your end users, anybody using this code, to access, make it public. Let them access it. Anything that they don't need to know about or don't need to use, make it private. Keep your private stuff private and your public stuff public. So your private variables, we talked about encapsulation briefly last time. I'll talk about it again now, and then I might never talk about it again this semester. But our private variables and private methods, these are encapsulated. We're hiding the details. Nobody needs to know. This is the beauty of encapsulation in private variables. Nobody needs to know that we have this overloaded helper method for the add method, and nobody needs to know that you have element data that's an object array and a separate variable called size to keep track of the size of an array list. You've never cared about this before, right? You've never used an array list, called arraylist.add and said, I wonder if it uses a helper method to do this, to actually add my element. It does, but we don't have to care because it's encapsulated. We don't have to care. But on the other side, we don't want to call this method because every time you add an element to an array list, you don't want to have to specify the value you want to add, what the underlying array is in the array list, and the current size of that array list. No, you want to say, add this thing. And that's it. That's how we want to use this code. So we have the public interface, that's how we use the code, and then the private details that are encapsulated and hidden from us. We never have to care that this exists. We never have to care what instance variables an array list uses or how it uses them or what this grow method does. We don't have to care about that until 250 when you're graded on it. But we don't have to care about that as end users of this code because of encapsulation. We don't have to know what the details are, care what the details are, and the authors of this code can hide those details from us using encapsulation. And then anything we do care about, they're going to make it public. And these are the things we care about. Anything that's public, this is saying, here's how you actually use an array list. I got these two constructors. You can choose which one you want to use. You can ask me for my size. Yeah, it is just a getter method. But you don't have to care that this underlying variable exists. I would always thought it would go to the array and say element data dot size. It actually can't do that for reasons, but we don't have to care what those reasons are. We just call the size method, and it'll get the size. Get, great. That's how I want my get method to use. Add, this is how I want my add method to work. That's how I want my methods to work. Those are the public methods, and this is something called our API, our Application Programming Interface, which is a term that gets way, I don't even know if it's overused, but it's used a lot in computer science. You're going to hear this term a lot, and it's somewhat hard to define. You'll probably get different definitions if you ask 5 different people, you get 5 definitions. It's one of those things. My definition is it's however 2 pieces of code interact with each other. That's the definition I like the most. So when your code is going to interact with the ArrayList code, it's going to interact using its API, which are all the public methods, or sometimes called its public API. That's how we're going to interact with the ArrayList code, through all the public methods. And if it had a public variable, you shouldn't see those in Java, but it would be the public state and behavior. So any methods you make public, you're saying this is how the outside world can interact with my code. Any details that they don't have to care about, encapsulate it using private methods and private variables. Yeah.
So this keyword, the word's kind of like having a specific clone for a name, kind of like that.
Having a specific what name?
A specific clone for a name. Like
Clone. Kind of like an alias, or kind of like a nickname. An alias would be. This is just another way of saying, like P1 or whatever. You can think of it like that. If you, my player example is pretty far away on the sides, but if you can think of it like that, if I have player P1 and I do player1 dot some method, that method gets this, which is like an alias for P1. You can think of it like that because they're both storing the same reference, so they refer to the same object. So
it's kind of like a faster way, like a pre-built thing to grab it.
Yeah, because if it didn't work like this, if we didn't have this in every non-static method, we would end up adding a parameter. We would say variable E of type E, comma, array list. Something like we just don't have to add that extra parameter because we almost always would want that. It's fairly rare that you're going to have a non-static method where you don't want to access the state of the object that you're working with. So Java just says, let's do that automatically. Let's just add that to every single method and just have this appear out of nowhere. That would be annoying. If we had to add every single one of these methods would have to have, like all of our player methods would have to have another parameter of type player. Every single one of them we'd have to add. So Java just makes it automatic. It says, don't bother, I'll do it for you. And static, I said this a bunch of times, but static belongs to the class, and non-static belongs to the object. And this ArrayList dot is the same as if we didn't say ArrayList dot. It's going to look in the class for a variable of that name. Then it'll look in this dot. It'll look in the objects of that type, see if there's a variable of that name. It finds it in the class, so it's going to use the class one. Or you can be explicit and say ArrayList dot. That makes it very clear that it's in a static variable. So there's only one copy of this variable belonging to the ArrayList class. There's only ever one copy of this. But these two variables, these instance variables, there's copies of these for every single ArrayList object. Every ArrayList object has these two variables. They do not have this variable. It belongs to the ArrayList class, which is there's only one class ever. There's only ever one ArrayList class in the Java util package. I have to qualify that. Little asterisk. You can create your own ArrayList class, named ArrayList, but it'll be in a different package. And wouldn't be what, it would just be confusing. Don't do that, please. But you could. Whenever I say method, I mean non-static method. On your programming test, if I say write a method that does X, Y, and Z, and I never mention the word static, that's a non-static method. Bless you. Which will be almost all methods for the rest of the semester. They'll almost all be non-static. There's a few methods. I think task 6 and 7 have a couple of them. If I remember which ones they are. I think it's 6 and 7. We'll have a couple, but we'll talk about that when we get there. So static, we won't use too much, but it is still useful. We won't use within 116 that much. It is still useful. For example, the math class. This is a class with nothing but static methods. Math class is all static. Static methods, static variables, static, 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 everything's static, except a constructor. Constructors can't be static. And when you when you use the math class, it's auto-imported. You just say math.py, and that's going to give you the constant pi with pi out to as many digits as can fit in a floating point double. Math.e, math.tau, and for some reason, I'll never understand this one, but degrees to radians and radians to degrees, which would maybe be useful constants to have, but they're private, so we can't access them. So the math package math class locks those down and doesn't let us access them. And then all of its methods are static. We say math.abs. It's a static method. Math.pow. Math.sign. We're calling those methods through the math class because they're static methods. And it doesn't make sense for the math class to be instantiated because it doesn't make sense for the math class to have any state or objects of, well, the class too. Classes or math objects wouldn't make sense for any of them to have state, to have some variables that vary in the math class. Doesn't make sense. So the writers, the authors of the math class went as far as saying, you can't instantiate this, made a private constructor. You can't instantiate the math class, even if you wanted to. Every single class does have to have a constructor. So the math class says, no, that constructor is going to be private and you can't access it. And just before anyone calls me out on it, if you don't explicitly write any constructor, you'll get what's called the default constructor, which is no parameters and no code in the body. So technically you can do new problem set in your task 1 code. You can instantiate the problem set class. Doesn't make sense to. Everything's static in there. It's just 3 static methods. But you can because you get the default constructor. If you want to disable that, you have to explicitly say, no, make that default constructor private. Get rid of it. Don't let anybody access it. So nobody gets to instantiate the math class. And quickly, the toString, I'll have more to say about this when we talk about inheritance and talk about the mechanics of what's actually happening here. But you might want to, in programming task 2, start printing out your values to the screen. If you have a reviewer or a rating, you might want to be tempted to print those to the screen if you're afraid of the debugger. I think the debugger would just be a better tool, but I haven't found enough lecture time to really talk about it yet either. But you might be tempted to print them. If you print a class, if you print an object of a type of one of your classes to the screen, you'll get one of these. You'll get this stuff. There's going to be the fully qualified name, which is package.name of the class, the @ symbol, and then some random hex value, which is related to its reference, but isn't exactly its reference. It's some convoluted Java thing that it prints, which is almost never what you want. You really never want this printed to the screen. So what you can do is add a toString method. If you add a public method named toString with a capital S, takes no parameters and returns a string. If you write a method with exactly that signature, it is a special signature, kind of like the main method that has to be exact, and then have it return some string, then when you print your object to the screen or a reference to your object, if you give a reference of your object to the printline method, to be exact, it'll print out whatever this method returned for that specific object.